Introduction to Proofs, Part 3. So, we have finished discussing direct proof. So, indirect proof and proof by vacuous and trivial. So, we have also another method for indirect, which is contradiction. So, today we're going to focus on proof by equivalence. So, proof by equivalence or biconditional. To prove a theorem that is a biconditional statement, we have to show that P implying true, implying Q, and Q implying P are both true. So that means we have this to be true, and its converse should also be proven. Now, you could use any method. For example, if n is an integer, n is even if and only if n squared is even. So first off, let's understand the meaning of if and only if. So, for example, in this case, if I will let this to be a, n is even, and b, n squared is even. So if and only if is the biconditional statement. But what it means basically is, say if you have a, if and only if b, so it really means two things. You have a if b and a only if b. From this, you could come up with the logical statement. So a if b is basically b as the antecedent implying a, and you have a only if b is basically a implying b. So together we have this as the by implication, which is a if and only if b. So this is basically the a way of understanding a biconditional with if and only if. So you have this a if b giving you the implication, and a only if b giving you the converse of the first one. Okay, so with this understanding, in this example, therefore, we have to prove two things. So we have to prove that if n is even, then so if n is even, then n squared is also even. The second one will be the converse. So its converse will be if n squared is even, so then n is also even. So we could solve it. First one, we could use a direct proof. So using direct proof, we could first assume that your hypothesis is true. So that means n is even, and this will be true. So n is equals to twice of k. Secondly, we could show that the conclusion is also true. So n equals 2k squared, and you have n squared is equals to 4k squared. And is it even? Is 4k squared even? So if we factor out the 2, so this will be equals to 2 times 2k squared. And if you let this to be any number, maybe m, which is also an integer, therefore this will become equals twice of m, and therefore that is an even number. So this direct proof takes care of the first one by direct proof. Now, how about the second one? So for the second one, if, as you notice, if n squared is even, then n is also even. The second statement, or the consequent, is simpler than the first statement, or the antecedent. So that's a heuristic to follow, that if the second statement is simpler, then it's better to use the contrapositive. It's not a rule, but it's merely a heuristic. So that means in this one, the second one, let's try to use the proof by contraposition. So with contraposition, first you're going to assume we're going to assume that the hypothesis is true. But the hypothesis this time around is the not of Q. So this is the hypothesis, which will be n as an odd number. So if n is an odd number, then it is equals to twice of k, where k is an integer. And secondly, we're going to show that the conclusion is also true. Again, the conclusion here will be the net of b, which is n squared is odd. So n squared is odd. So we could first one is odd, so 2k plus 1. So we could try to square the first assumption. So n is equals to twice of k plus 1 squared, and you have n squared is equals to 4k squared plus 4k plus 1. And is this number even or odd? Well, we could factor out the 2. So for example, this will become 2k squared plus 2k quantity plus 1. And if we let this whole thing, if we let this to be, say, number m, we will end up with twice of m plus 1. So this is the form of an odd number. So therefore, n squared is an odd number. Hence, we have proven the contraposition. And if you have proven the contraposition, it's equivalent to proving the original implication, because they're logically equivalent. So as an exercise, you could try this one. So if n is positive integer, then n is odd if and only if n squared is odd. And it's very similar to the discussed problem. That's it.